Tonight, you're not just closing your eyes, you're stepping into the oldest story you've ever been told, the story of how everything began. But don't get too comfortable. This isn't the neat schoolbook version with a single spark, a single bang, and a tidy universe rolling out like a red carpet. No, tonight we're going to tug at the seams of that story until they unravel. You might not survive this version of reality, at least not the cozy certainty of it. Picture the firework. It's the first image most of us are given. A firework frozen in bloom, galaxies arcing outward like glitter. A single point of infinite density, hotter than you can imagine, suddenly expanding 13.8 billion years ago. Boom! Time itself ignites, space blossoms, and you and I are inevitable, written in the sparks. It sounds cinematic, too cinematic. But here's the hook. What if the story isn't that clean? What if the cracks in the Big Bang are wide enough to drive a galaxy through? Before we fall head first, take a breath. If you genuinely enjoy wandering down these cosmic rabbit holes with me, consider subscribing, but only if you really like the way we do this here. Now, dim the lights, let the noise of the day sink into silence, and let's ease into tonight's journey together. You shuffle forward, carrying the heavy assumption that cosmologists had the origin of everything nailed down decades ago. After all, textbooks present the Big Bang as fact, not theory. But rewind to the 1920s and meet Edwin Hubble peering through glass at fuzzy smudges of light. He realized they weren't stars in our own galaxy at all. They were galaxies themselves, sprinting away from us. The farther, the faster. Like raisins swelling in rising bread dough, space itself was stretching. That discovery gave the Big Bang its strongest leg. Space expands, therefore it must once have been smaller. Therefore, rewind far enough and bang, a neat conclusion. But historians still debate whether Hubble himself ever believed in the fireworks show. He presented the data, but whether he bought into the narrative, that's uncertain. He may have been more cautious than the myth suggests. Here's where the analogy bites back. It's like watching a balloon inflate for 2 seconds and then declaring what it looked like before it was manufactured. Sure, maybe you're right, but maybe that balloon lived a whole life before you noticed. The Big Bang rests on that assumption. Roll back the clock, pile matter into a point, and voila! Yet, from the beginning, astronomers scratched their heads. Where did the bang happen? In space? But space itself was supposed to emerge with it. What exploded exactly? And into what? And then there's the name itself, Big Bang. You imagine fireworks and thunder, but that phrase started as a joke. In 1949, British astronomer Fred Hoyle mocked the whole idea on a radio broadcast. He championed his own steady-state model, where the universe always existed, continuously creating matter to fill in the gaps. His jab stuck. Imagine giving your friend a sarcastic nickname, only for it to follow them through history, textbooks, and bedtime stories alike. Fast forward to the 1960s, when the theory claimed its greatest prize, the cosmic microwave background radiation. Two radio astronomers, Arno Penzias and Robert Wilson, were trying to fix a maddening hiss in their antenna. They thought it was pigeons roosting in the dish, or maybe pigeon poop. They scraped, they cursed, they even climbed inside to clean it, but the hiss remained. Turns out they had stumbled upon the faint afterglow of the Big Bang itself, a whisper of heat from the newborn universe, stretched thin across billions of years. That discovery should have been the smoking gun. And yet, like all good mysteries, it raised more questions than it answered. Because that glow wasn't perfectly uniform. It shimmered with tiny fluctuations, ripples too precise to ignore. Scientists argued, are these flaws in the story or clues to a deeper one? If the Big Bang were as clean as advertised, the universe should look smooth. But we don't live in smooth, we live in clumpy. Galaxies bunch together, voids yawn between them, and cosmic structures seem to have formed faster than they should have. That's when cosmologists started adding patches, cosmic inflation, dark matter, dark energy. Like a student padding an essay with extra paragraphs, the Big Bang theory grew heavier, not neater. Think about it. The Big Bang is less a solved mystery and more a draft patched together with duct tape. Was it the start of time itself, or just a dramatic shift in something older? Did before even exist? Or is before a word that means nothing when time itself hasn't yet unspooled? You lie there, staring up into a ceiling of stars, and the ground beneath your understanding shifts. The Big Bang may not be wrong, but it may not be the whole story either. It's like discovering that your favorite childhood movie had 20 minutes cut from the beginning. You thought you knew the plot. Now you're not so sure. The universe doesn't give up its secrets easily. It teases, it misleads, it plants pigeon poop in your experiments. And tonight, as you drift through this story, you begin to see the cracks glowing faintly in the cosmic walls. A neat bang, maybe. Or maybe the truth is stranger, something older, something without a beginning at all.
You lean into the hiss, that faint static hum, like an old television left tuned to the wrong channel. It's not just noise, it's the cosmos whispering, the cosmic micro-background, they call it. It sounds clinical, but really, it's the universe singing to itself across every square inch of sky. Imagine lying flat under the stars, but instead of constellations, the whole dome glows faintly in microwaves you can't see. That glow is said to be the afterglow of the Big Bang, the last heat of creation stretched thinner than silk across 13.8 billion years. A kind of lullaby, steady, patient, everywhere. Here's a strange thought. About 1% of the snow on those old TV sets, the kind with rabbit ear antennas, came from this very radiation. That hiss, that flicker you ignored while flipping channels on Saturday mornings, was a direct echo of the universe's birth. The cosmos hiding in your living room, tucked between cartoons and commercials. But let's rewind to 1964. Arno Penzias and Robert Wilson weren't chasing poetry. They were just two astronomers irritated by an annoying hum in their horn-shaped antenna. They checked their cooling systems, replaced parts, even shoveled out what they politely called white dielectric material. That's science speak for pigeon droppings. Yes, our strongest evidence for the Big Bang almost got scrubbed away with bird poop. But the hiss wouldn't die. No matter how they cleaned or recalibrated, it lingered. Eventually, they realized they had stumbled into something profound, the afterglow of creation itself. For their accidental discovery, they won a Nobel Prize. The pigeons, tragically, didn't make it into the acceptance speech. The cosmic micro-background, CMB, became the Big Bang's crown jewel. Smooth, nearly uniform, it matched predictions. If everything began hot and dense, then the leftover heat should still glow evenly. But the closer scientists looked, the more wrinkles they found. Tiny fluctuations, temperature differences of millionths of a degree. Hardly noticeable, yet cosmically important. Those faint ripples were the seeds. Without them, galaxies, stars, and planets wouldn't exist. Every structure we see today, the Milky Way, the Earth, you lying in your bed, traces its ancestry back to those subtle variations. Like faint brushstrokes on a cosmic canvas. Historians and physicists still argue. Do these fluctuations confirm the Big Bang or betray its weaknesses? On one hand, they're exactly what you'd expect from a hot, dense beginning. On the other hand, their precision is almost suspicious. Too tidy, as though sculpted. Imagine stirring cream into coffee and finding perfect spirals instead of random swirls. Possible, yes. Probable, debatable. And then come the anomalies. Vast cold spots in the CMB, regions where the hiss dips strangely low. One in particular is so enormous and improbable that some fringe thinkers whisper it might be a scar left behind by a collision with another universe. Picture universes as bubbles in a crowded bath, jostling and bumping. Did one crash into ours, leaving behind a bruise still visible today? Mainstream physicists are cautious. Most argue the cold spot is just a statistical fluke, a cosmic coincidence. But even then, it points to a deeper puzzle. Why is the CMB so uniform at all? Regions on opposite ends of the universe should never have spoken to each other, never had time to trade heat. Yet their temperatures match almost perfectly. This is the horizon problem, the cosmic equivalent of two strangers living on opposite sides of the planet, somehow dressing in the exact same outfit. The fix? Inflation. A brief, faster-than-light expansion in the universe's first trillionth of a second, stretching everything into uniformity. Inflation solves the puzzle neatly, but it feels suspiciously like a patch, like a sudden plot twist inserted halfway through a novel just to explain away a continuity error. Did it really happen? Or is it a cosmic handwave smoothing out the rough edges of an untidy universe? Here's another eerie layer. Those CMB ripples aren't just random. They're echoes of ancient sound waves, baryon acoustic oscillations, as astronomers call them. Pressure ripples sloshing through the plasma of the infant universe, frozen in place when atoms first formed. What you see in the radiation is literally the aftersound of creation, a fossilized music humming forever across the sky. But then the unsettling thought creeps in. If the hiss is the birth cry of our universe, is it really proof of a beginning or proof of something older echoing through? The cold spot, the wrinkles, the uniformity. They don't just answer questions, they ask new ones. You close your eyes and listen. The static isn't static anymore. It's alive, patterned, mysterious. A message written across the whole sky, and no matter how many times scientists decode it, they always find another line they missed. And just like that, you realize the hiss is less like a lullaby and more like a cosmic riddle humming in the dark, daring you to stay awake.
You stand at the universe's childhood doorstep, and suddenly it explodes, not with fire, but with speed. Expansion faster than light itself, in an instant so brief you couldn't blink fast enough to catch it. This is inflation theory, the great patch sewn across the Big Bang's fraying edges. Without it, the neat story unravels. With it, the universe becomes stranger, almost theatrical in its complications. The idea was born in the late 1970s and early 80s when physicist Alan Guth found himself wrestling with an ugly paradox. He noticed that the universe looked suspiciously uniform, too smooth, too flat, too synchronized. Regions that should never have touched, light years, billions of light years apart, were somehow wearing the same cosmic outfit. It didn't make sense. Then came the eureka. If, for just a split second, the early universe inflated at unimaginable speed, stretching faster than light, ballooning in size by absurd factors, then all those problems dissolve. The horizon problem? Gone, because what looks separate now was once close enough to trade information before inflation yanked it apart. The flatness problem? Solved, because any curvature would have been iron flat, the way a baker stretches dough until every bubble disappears. Even the puzzle of why we exist in clumps rather than uniform soup? Explained by quantum fluctuations, stretched during inflation into the seeds of galaxies. It was brilliant. Too brilliant. Imagine discovering a single pill that cures your headache, your heartbreak, and your tax debt. You'd be grateful, but you'd also raise an eyebrow. Guth's inflation was that pill, a theory that fixed too much, too neatly, too fast. Historians still argue, was it genius physics or desperate patchwork? Here's the quirky twist. Inflation doesn't just explain our universe, it predicts a multiverse. Each bubble of inflation could spawn a separate cosmos with its own laws, its own chemistry, its own fate. Most fizz out instantly, but some stabilize, like ours, long enough to grow stars, planets, and late-night YouTube videos. Which means you, lying here, are not inevitable. You're a lottery ticket that happened to hit. Unsettling, isn't it? But inflation has its own cracks. First, the inflaton field, the mysterious driver of the expansion, something no one has ever detected. The math demands it, but physics shrugs. It's the cosmic version of a kid blaming an imaginary friend for a broken lamp. Second, the graceful exit problem. Inflation should have been unstoppable, tearing the universe apart into eternal emptiness. Yet somehow it stopped, handing off neatly to normal expansion, just at the right moment, with just the right conditions. Like slamming your brakes on ice and stopping exactly at the traffic light. Lucky or suspiciously staged? Third, predictions. Inflation ought to leave behind a signature in the form of gravitational waves, ripples in space-time. In 2014, the BICEP 2 experiment in Antarctica thought they'd found them. Headlines declared victory, scientists cheered, and then the universe punked us again. It wasn't primordial waves, it was cosmic dust. Inflation's smoking gun dissolved into interstellar dirt. And still, many physicists defend it. They argue inflation is flexible, not broken. Critics counter that it's too flexible, able to accommodate any observation. Which raises the uncomfortable question. If your theory can never be proven wrong, is it still science? Or just a cosmic bedtime story with no ending? And yet, you can't deny its allure. Inflation explains why the sky glows almost evenly in microwaves. It explains why galaxies grew where they did. Without it, the Big Bang teeters on shaky ground. With it, reality itself feels stitched from something almost playful, a stage trick involving invisible fields and impossible speed. Here's the haunting add-on. Inflation might never stop. Even as you lie here tonight imagining galaxies drifting apart, somewhere in the endless expanse, space could still be inflating. New universes bubbling into existence beyond reach, forever. A cosmic foam of worlds, ours just one bubble in the froth. If that's true, then the beginning of the universe stops meaning anything at all. because beginnings are happening all the time, everywhere, always. You exhale slowly, unsettled. Inflation may have patched the Big Bang, but like duct tape on a leaky pipe, the patch is obvious. The story feels less like a solution and more like a setup. And the question hangs, if the universe didn't begin with a bang, what if it began with a bounce?
You drift deeper into the story, and suddenly the Big Bang feels less like a birth and more like a rebound. Not a spark from nothing, but a spring, a return, a bounce. Picture a trampoline in slow motion. It dips under weight, compresses, and then, whoosh, springs back upward. Now stretch that image across the cosmos. Collapse, compression, rebound. Not a singular firework, but a heartbeat. Inhale, exhale. Bang, crunch. This is the bounce model. A quiet rebellion against the neat, explosive beginning you learned in school. Instead of a universe emerging from absolute nothing, it imagines an eternal cosmos, cycling forever, collapsing, rebounding, breathing. The idea isn't modern. Ancient Indian cosmologies described a universe that expanded and contracted endlessly, the heartbeat of Brahma himself. Greek philosophers toyed with similar cycles, worlds rising and falling without end. And in the 20th century, physicists brushed off those myths and tried them on for size. In the 1930s, Richard Tolman proposed the oscillating universe, where cycles of trillions of years could follow one another like pearls on a necklace. Expansion, collapse, rebound. But Tolman was cautious. He calculated how entropy, disorder, would accumulate with each cycle, stretching each expansion longer than the last. Eventually, he warned, the cycles would sputter out. The cosmic accordion would sag, unable to bounce forever. Historians still debate whether Tolman truly doomed the idea, or whether newer physics might rescue it. Fast forward to today, and bounce theories are back with a vengeance. The ekpyrotic model, born from string theory, pictures our universe living on a brain, a multi-dimensional sheet. Every so often, our brain collides with another in the higher dimensional bulk. The collision doesn't annihilate them, but releases energy that to us looks like a big bang. Then the brains drift apart, only to crash together again someday. Bangs on repeat. Less once upon a time, more to be continued. You lie back and imagine it. Vast cosmic membranes colliding like cymbals in an invisible orchestra. Each crash sends sparks, galaxies, stars, you, flying outward. Each rebound is another verse in an endless rhythm. But here's the problem. The bounce has a hard time explaining why the universe looks so smooth and flat. Inflation, for all its flaws, does that job better. So bounce supporters have to get creative. Some argue that near the moment of collapse, quantum effects stiffen space-time, preventing a singularity and forcing a rebound. Others speculate that dark energy, the force accelerating expansion now, might one day reverse, pulling everything inward for the next crunch. Quirky twist, some even suggest black holes could act as seeds for the next expansion. In a collapsing universe, instead of vanishing, black hole cores might survive, scattering like cosmic buckshot into the newborn cosmos. The ultimate recycling program. Stars die, collapse, and their dense remnants help ignite the next bang. Efficient, if unsettling. Still, entropy lurks, stubborn as ever. Disorder should keep growing, cycle after cycle, until no bounce is possible. Unless the very laws change at collapse. Some dream that quantum gravity, the still elusive fusion of relativity and quantum mechanics, could reset the clock each time, wiping entropy clean, like hitting a cosmic reset button at every crunch. Comforting, isn't it? If the bounce is real, then the universe doesn't need a beginning at all. It just always was, always cycling, always breathing. You don't have to wrestle with the paradox of something from nothing. Instead, you can imagine yourself as one chapter in an eternal book. Your atoms borrowed from countless past universes, destined to be recycled in countless more. And maybe those faint anomalies we see, the infamous cold spot, the strange alignments in cosmic background radiation, aren't errors at all, but graffiti left by the last cycle. Fingerprints from a previous universe, peeking through the plaster of this one. Remember that neat balloon model you carried since grade school? Bounce theories tear it apart. Instead of a balloon swelling from a single point, the cosmos is an accordion, folding and unfolding forever. Bangs, crunches, bangs again. And here's the eerie lullaby. If the bounce is true, then you are not the first to lie under these stars. Others before you dreamed their cosmic dreams. Others after you will dream again. You smile in the dark. If the Big Bang wasn't the beginning, maybe there never was one.
You close your eyes and sink into something stranger than bangs or bounces, stranger than eggs or inflations. A jittering sea, restless and alive, where nothing itself fizzes and sputters. This is quantum foam, the stage where reality trembles at its smallest scales. Here, the vacuum isn't empty. Even when you strip away matter, radiation, and light, what's left isn't silence, it's boiling. Particles flicker in and out of existence so fast they barely count as existing. The void is restless, twitching, bubbling like soda left too long in the sun. This vision belongs to quantum mechanics, the trickster of physics. On the tiniest scales, certainty dissolves. You can't pin down a particle's position and momentum at once. Instead, reality plays dice. Particles appear, vanish, reappear, as though the universe is shrugging and saying, "Close enough." And this constant flicker means even nothing has weight. Even a vacuum pushes back. In 1948, Dutch physicist Hendrik Casimir predicted that if you placed two metal plates close together, the vacuum would squeeze them. Later experiments proved him right. The infamous Casimir effect. An invisible force, born not from matter, but from emptiness itself. A whisper from the foam. Physicist John Wheeler in the 1960s gave this froth its name, quantum foam. He imagined space-time itself warping at the smallest possible scales, twisting into wormholes and loops. At that level, the universe isn't smooth, but tangled, a mess of bubbles foaming into and out of existence. Historians still argue whether Wheeler meant it literally or metaphorically, but physicists took it seriously. Now, here's the unsettling leap. Some believe our entire universe may have been just one such bubble, a quantum fluctuation that didn't collapse. Out of the infinite jitter, one bubble expanded instead of popping, stabilizing into a cosmos, ours. Imagine your life, your stars, your dreams, born of a cosmic hiccup. It sounds absurd, but in the 1970s, physicist Edward Tryon suggested exactly that. Our universe is simply one of those things that happens from time to time. Casual, almost flippant, like the birth of reality was no more important than a passing ripple in the void. The math is tempting.
Because maybe the total energy of the universe is zero. Positive energy exists in matter, you, me, stars, galaxies. Negative energy lurks in gravity, pulling it all together. Add them up and they cancel. If the cosmic books balance, then perhaps the cost of creation was nothing at all. A free lunch, charged to a vacuum that never sends the bill. But then the doubts creep in. If fluctuations can spawn universes, why don't they happen constantly? Why isn't a new reality budding around you like mushrooms after rain? Maybe it is, some argue. But each universe expands into its own pocket of space-time, invisible from ours. A cosmic mushroom field where each stalk is a world. And then comes the paradox of time. If fluctuations happened before the universe, doesn't that imply time already existed? But if time itself began with our universe, then what exactly was fluctuating? It's like imagining waves on an ocean that hasn't been poured yet. Even physicists shake their heads here. Still, the foam keeps whispering. Black holes, for instance, might connect to it, sprouting wormholes at microscopic scales. Some theorists dream that our universe itself is a baby universe pinched off from the quantum froth of a larger one. Cosmic reproduction, worlds budding like cells dividing. Remember the bounce model? Cosmic cycles on the grandest scale. Quantum foam is the microscopic cousin. Instead of whole universes rebounding, it's tiny bubbles, most collapsing instantly. But once in a great while, one grows. And here you are, inside it. And here's the physicist's joke. Nothing is unstable. It sounds like comedy, but it's also prophecy. Nothingness cannot sit still. It is always trembling, always pregnant with possibility. If that's true, then perhaps nothing never existed at all. There has always been foam. There has always been something. You lie there staring into the darkness, and it no longer feels empty. The room itself hums with phantom particles. The silence between stars seethes with potential. Even your breath feels like part of a restless froth that refuses to vanish. And maybe that's the truest bedtime story of all. You were never born from nothing. You were born from a hiss, a foam, a flicker. The bang was just the first echo.
You've heard the old question, which came first, the chicken or the egg? Tonight, the universe asks a sharper version. Which came first, the cosmos or the egg that contained it? In ancient myths, the cosmic egg is everywhere. The Rig Veda of India speaks of Hiranyagarbha, the golden embryo floating in primal waters, cracking open to spill the sky and earth. The Greeks told of Orphic myths, where a silver egg hatched Phanes, the radiant god of creation. Even in China, stories describe the giant Pongu hatching from a cosmic shell, his body becoming mountains and rivers. Across cultures, the idea is eerily constant. Before stars, before time, there was an egg. And modern cosmology, to its surprise, echoes the myth. Because when you rewind the expansion of space, you arrive at something compressed, contained, potential, like an egg unbroken. Physicists call it the singularity, infinite density, infinite heat, a point where the laws of physics collapse under their own weight. It's the cosmic equivalent of a locked box you're forbidden to open. Peer inside and math crumbles. Relativity and quantum mechanics refuse to cooperate. Time itself becomes meaningless. Was there a before? The equations can't be said. But here's the tension. Maybe the singularity isn't real. Maybe it's just a placeholder, the way ancient maps filled blank spaces with dragons. When our equations fail, we label the void singularity. In truth, what lies there may be something richer, stranger, an egg waiting to hatch. Consider the Planck epoch, the first fraction of a second after the supposed bang, 10 to the minus 43 seconds. That's a number so tiny it barely counts as time. In that moment, all four fundamental forces, gravity, electromagnetism, strong nuclear, weak nuclear, may have been one. A single yolk, undivided, before cracking into the forces we know today. The cosmic egg broken into pieces, each piece shaping reality. Some physicists whisper about string theory and loop quantum gravity, daring to describe the inside of the egg. In these models, space-time isn't smooth, it's granular, woven from loops or vibrating strings. Instead of a singularity, the egg might have a finite, structured core, capable of bouncing, birthing, repeating. The nothing we imagined is replaced by a deeper fabric humming beneath. And here's the haunting thought. The egg doesn't just describe the beginning, it describes endings too. Stars collapse into black holes, tiny singularities, tiny eggs. Each one a place where the known laws fail, and where new realities might bud. Some even speculate that black holes could be cosmic wombs, seeding baby universes, which means every egg hatches into more eggs, a nesting doll of creation. But if the universe was an egg, what cracked it open? Was it random fluctuation, the foam of nothingness we spoke of? Was it an external strike, two brains colliding, membranes smashing shells? Or was it inevitable, as natural as an embryo hatching when the time is right? Think of it this way. Every culture dreamed of the egg because eggs are potential made visible. Fragile shells holding life, mystery, transformation. To call the beginning an egg is to say what came before was hidden, gestating, waiting. And maybe that's still true. Maybe our universe is still inside a larger egg we haven't recognized. You roll onto your side and imagine the shell, smooth, silent, waiting. On one side, the nothing you can't imagine. On the other, stars, galaxies, laughter, grief. The shell shatters, and here you are. But the question lingers, feather light yet unshakable. If there was an egg, who or what laid it? Or is that question itself the trap? Maybe the egg is eternal. Maybe the chicken never existed at all. And so you lie there, caught between myth and physics, realizing that the oldest stories weren't so different from the newest. The golden embryo, the singularity, the Planck epoch, they're all ways of circling the same mystery. The egg before the chicken, the question before the answer, the silence before the song.
Time. It feels like the most natural thing in the world. You watch it flow with the tick of a clock, the rise of the sun, the slowing of your own breath as you drift closer to sleep. But tonight, the universe leans close and whispers something unnerving. Time may not be what you think it is. The Big Bang story, as you first learned it, claims time began with the bang. No before, no ticking clock. The egg cracks, the firework blooms, and then time begins. Before that, not just empty, not even meaningless, simply non-existent. Like asking what's north of the North Pole. And yet your mind rebels. You can't help but ask, what was before? If the bang was the beginning of time, how did it begin in time? Doesn't the word beginning already smuggle in the idea of time ticking? This is the paradox, the headache at the heart of cosmology. Let's linger with the ancients for a moment. The Greeks pictured Kronos, the god of time, a serpent coiled around the egg of the universe, squeezing it open. In Hindu thought, time wasn't a line, but a cycle. Kalpas, vast ages spinning endlessly, where creation and destruction dance forever. The Maya watched time as nested calendars, turning wheels within wheels. For them, there was never a before, there was always time. Modern physics struggles between these visions. On one hand, relativity insists time is part of the fabric of the cosmos, woven with space itself. No universe, no time. On the other hand, quantum theories hint that time might be emergent, a byproduct of deeper processes, not fundamental at all. Like the way heat emerges from the jitter of atoms, though no single atom contains it. If time is emergent, then maybe it didn't need to begin. Maybe it's like mist forming over water, or music rising from vibrations. When the universe reached a certain threshold, time condensed, appeared, became perceptible. Before that, reality had no ticking, no direction, no arrow. But what if time is eternal? Some theories argue that our universe sprouted from a larger, timeless background, a quantum sea where before and after mean nothing. In that sea, what you call the beginning might just be a local event, like foam rising on the crest of a wave. The water was always there, even when the bubbles weren't. And then the arrow of time. Why time feels like it flows in one direction. Physics is mostly reversible. Equations don't care if you run them forward or backward. Yet your coffee cools, never reheats itself. You age, never grow younger. The universe expands, never contracts. Why? Because of entropy. Disorder always increases. The arrow points toward messiness, toward heat death, toward endings. But here's the riddle. If entropy drives the arrow, what set it in motion at the start? At the Big Bang, entropy was low, astonishingly low, a state of improbable order, like a deck of cards arranged perfectly by suit and number. Why would the universe start so improbably neat, just to unravel? Some say it didn't. Some say we misread the arrow. In a bounce model, for example, entropy might reverse with each contraction, sending time flowing backward for the collapsing side. Imagine another you, another cosmos, living life in reverse, breathing in as you breathe out. And here's the most unsettling whisper of all. Maybe time is an illusion altogether. Some physicists, like Julian Barber, argue that what exists are nows, static snapshots, timeless instants. What you feel as time flows is your mind stitching snapshots together like frames of a film. If that's true, then the Big Bang wasn't a beginning. It's just one frame among countless others, all coexisting in a vast, timeless gallery. You lie very still now. The ticking of the clock beside you feels both comforting and suspicious. Is it really moving forward, or are you simply sliding across still pictures, one after the other? The ancients said Kronos squeezed the egg until it cracked. Modern physics says maybe time cracked with it. But tonight, as you listen, another possibility lingers. Maybe the egg was never closed. Maybe there was always time. Or maybe there never was.
You thought you were following the plot. Big Bang, expansion, galaxies, a universe illuminated by stars and nebulae. But then the story drops its twist. Everything you can see, planets, people, fireflies, the glow of 1 billion suns, makes up less than 5% of the cosmos. The rest is invisible, untouchable, inscrutable. Welcome to the hidden script, dark matter and dark energy. Let's start with the shadows that bind, dark matter. The 1930s gave us the first clue when Swiss astronomer Fritz Zwicky studied the Coma Cluster, a swarm of galaxies bound together in deep space. By all accounts, the galaxies should have been flying apart like sparks from a fire, but they weren't. Something unseen was holding them. Zwicky called it Dunkel Materia, dark matter. At first, no one listened. Zwicky was eccentric, prickly, prone to insults. But decades later, astronomer Vera Rubin confirmed his suspicion. She measured the rotation of galaxies and found stars at the edges spinning far too fast. According to gravity's rules, those stars should have been flung away. Yet they clung stubbornly, orbiting like beads on an invisible string. The only explanation, some unseen mass was anchoring them. Today, we believe dark matter makes up about 27% of the universe. We don't know what it is. It doesn't shine, it doesn't absorb light, it doesn't collide with normal matter in any way we can easily detect. It slips through walls, through you, through Earth, as though solid things are smoke. Some imagine exotic WIMPs, weakly interacting massive particles. Others suggest axions, feather-light particles filling space like mist. And some dream bigger, primordial black holes, relics from the early universe, hidden everywhere. The unsettling part is that dark matter might be passing through your body right now, countless times per second, and you'd never notice. It's the scaffolding of the cosmos, invisible yet real, guiding galaxies into clusters, sculpting the large-scale web of the universe. Without it, stars wouldn't have gathered, planets wouldn't have formed, and you wouldn't be lying here wondering about it. You exist because of something you cannot see. And then comes the darker twist, dark energy. In 1998, two teams of astronomers, working separately, racing toward glory, measured distant supernovae, exploding stars that serve as cosmic mile markers. To their shock, the explosions were dimmer than expected. That could only mean one thing. The universe wasn't just expanding, it was accelerating. Something was pushing it apart, faster and faster, like a hidden hand on the throttle. They called it dark energy, not because they understood it, but because they didn't. It's thought to make up nearly 70% of the universe, and it behaves like a repulsive gravity, an energy woven into empty space itself. Left unchecked, it will stretch galaxies so far apart that trillions of years from now, night skies will be empty. Every star outside our own galaxy will vanish from view. The universe will go dark, cold, silent. Some imagine dark energy as the cosmological constant, the fudge factor Einstein once introduced and then abandoned as a mistake. Others suspect it's something dynamic, a field evolving over time.
A few radical thinkers wonder if our measurements are wrong, if the very laws of gravity need rewriting. But here's the poetic symmetry. Dark matter holds the cosmos together. Dark energy tears it apart. One binds, one unbinds. Two invisible actors performing a cosmic tug-of-war across eternity. And then the eerie thought creeps in. If 95% of reality is hidden, then what you see, the stars, the galaxies, your reflection in the mirror, is just a sliver, a surface, a shadow. You live in a universe where the stage props are visible, but the real play is happening in darkness. Imagine closing your eyes. You might think you're surrounded by nothing, but in truth, you're swimming in a sea of invisible forces. A sea where the majority of the cosmos hides. A sea where reality whispers secrets you can't hear. Dark matter keeps your galaxy from flying apart. Dark energy is prying it away from its neighbors. You're balanced between two invisible hands, one pulling inward, one pushing outward, both stronger than anything you can see. And maybe the Big Bang wasn't the beginning after all. Maybe it was just the moment these hidden actors first stepped onto the stage.
You thought the story was wild enough. Bangs, bounces, eggs, foam, dark forces unseen. But now the universe leans closer and whispers a word that makes cosmologists grin and philosophers sweat. Multiworld. Picture a bubble bath. Each frothy sphere is a universe, expanding, shimmering, colliding. Ours is just one bubble among countless others, bobbing in an endless froth. That's the simplest way to imagine it, the bubble multiworld, born from inflation theory. If inflation didn't stop everywhere at once, and the math suggests it didn't, then new universes could still be inflating right now, eternally, each one sealed off from the others by stretching space. But that's only one version. There are others, stranger. The brain multiworld, whispered by string theory, pictures our cosmos as a membrane floating in higher dimensions. Sometimes brains collide, birthing universes in the sparks. Other times they drift alone, whole realities passing silently like ships in an unseen sea. Our Big Bang could have been just such a collision, one brain bumping another, the aftermath glowing as stars. Or consider the many worlds interpretation of quantum mechanics. Every quantum decision, every time a particle chooses left or right, every time you choose tea or coffee, splits reality. One universe where you sip tea, another where you pour coffee, another where you did neither because you dropped the cup. In this view, universes proliferate endlessly, fractal and branching. You are not one person, but countless variations, walking parallel roads forever unseen. And then there's the mathematical multiworld, the idea that every consistent set of mathematical laws exists as its own universe. Not only different constants, but entirely different rules. Universes with no gravity, no atoms, no time as you know it. Infinite realms of possibility, most lifeless, a few hospitable, ours among them. Here's the unsettling part. If infinite universes exist, then everything possible must happen somewhere. A world where dinosaurs survived. A world where Earth never formed. A world where another you lies awake, listening to another version of this story. But is this science or speculation? Historians of cosmology note that the multiverse grew out of necessity, a way to soften inflation's rough edges, a way to dodge the fine-tuning problem. Why do the laws of physics seem so precisely balanced for life?
Why do constants like gravity's strength, the electron's charge, fall into the razor-thin ranges that make stars and chemistry possible? One answer, they're not special. They're random. We just live in the bubble that happened to get the recipe right. The multiverse turns miraculous luck into statistical inevitability. Yet critics bristle. If other universes can never be observed, how can we call them science? Is the multiverse just a myth wearing a lab coat? A bedtime story for physicists who dislike the word miracle? And still, evidence teases at the edges. Remember that cold spot in the cosmic microwave background? Some whisper it's a bruise from another universe brushing against ours. Some claim high-energy collisions might, just might, reveal leakage from higher dimensions. Nothing proven, nothing solid, but the hints remain. You lie very still. The thought is dizzying. If the multiverse is real, then the Big Bang wasn't the beginning of everything. It was the beginning of our bubble, just one among endless others, some inflating as we speak, some collapsing, some alien beyond comprehension. And here's the lullaby twist. Maybe this is why the universe feels so mysterious, so tuned, so improbable. Because we are like fish in water, unaware of the sea beyond the bowl. We live inside a bubble, staring at its glowing walls, never realizing there are other bubbles drifting all around. If so, then you are not unique. Not even your universe is unique. You are an echo among echoes, a story among stories, one dream among infinite dreams.
You've walked through bangs and bounces, eggs and foams, bubbles and brains. But underneath it all lurks the oldest, simplest, and most terrifying question: why is there something rather than nothing? At first glance, nothing feels easy. A dark room, a blank page, silence. But that's not nothing. That's absence inside something. True nothing would mean no space, no time, no laws, no potential, not even a stage for emptiness to sit on. And yet, here you are. Something happened. Philosophers wrestled with this long before physics. Parmenides in ancient Greece declared, "Nothing cannot exist. To speak of it is nonsense. Existence," he argued, "must always exist in some form." Centuries later, Augustine of Hippo meditated on the Genesis phrase, "in the beginning." Did God create the world in time? Or did he create time itself alongside the heavens and the earth? If so, then there was never a before. There was nothing. Modern physics twists the knife deeper. Remember quantum foam? Even empty space jitters. Even the vacuum seethes with virtual particles. So perhaps nothing is impossible. The universe didn't emerge from nothing. It emerged from a restless background that only masquerades as nothing to human eyes. Some physicists, like Lawrence Krauss, argue the cosmos could arise naturally from quantum laws. If the total energy balances to zero, if fluctuations are inevitable, then maybe universes bloom like weeds in the garden of nothingness. But here's the catch. That still assumes the existence of quantum laws, rules, equations, mathematics. That's not nothing. That's a hidden scaffold, a grammar beneath reality. And so the paradox stands. You can explain the Big Bang, inflation, dark energy, multiverses, but none of them remove the deeper question. Why is there a stage for any of it? Why are there laws to guide the foam, constants to sculpt stars, rules to whisper galaxies into being? Why not silence forever? Theologians answer with God. Mystics answer with eternity. Some scientists shrug and say the question itself may be malformed, born from human brains evolved for counting sheep and planting crops, not for solving cosmic riddles. Maybe nothing isn't real and never was. And yet, you can't let it go. The thought presses against your chest like the weight of a dark sky. Imagine, if you dare, the alternative. A reality where not even time ticks, not even emptiness hums, not even questions form. That absence would swallow everything. Your thoughts, your story, even the idea of absence itself. And maybe that's why you can't picture it, because your very mind is part of something, and nothing has no room for minds. To ask why something is already to admit you live inside the answer. Still, the problem lingers like a splinter. If nothing is impossible, then existence is necessary. The universe must exist, always, in some form. Bang or bounce, bubble or brain, dream or God, it was always inevitable. And if that's true, then maybe you can rest easier, because the story doesn't hinge on fragile beginnings or endings. It simply is. Existence doesn't need a reason. It only needs itself. You roll onto your back and stare at the ceiling, the shadows shifting like faint galaxies. The question remains unanswered, but it has shifted shape. Nothing may not exist. Maybe it never did. Maybe it never could. Which means the real problem isn't why there is something rather than nothing. The real problem is why you ever thought nothing was possible in the first place.
You've drifted through beginnings, through foams and eggs and bubbles. But now the universe turns its face toward endings, and its name is entropy. Entropy is the quiet accountant of reality. It measures disorder, the spread of energy, the unraveling of order into chaos. Pour milk into coffee and watch the swirl vanish into a uniform brown. That's entropy, smoothing, blending, dissolving. Leave a house alone for decades and dust wins, walls sag, order collapses. That's entropy too. Physics tells you entropy always increases, always. The second law of thermodynamics is merciless. Systems grow messier, not neater. You can build castles, but the tide of entropy will eventually swallow them. You can light a fire, but its heat will scatter, impossible to recollect perfectly. And this law doesn't just haunt your kitchen or your attic, it stalks the universe itself. The Big Bang was improbably low in entropy, astonishingly ordered, like a deck of cards sorted perfectly. From that pristine state, entropy has been rising ever since. Stars burn, galaxies churn, heat scatters. The arrow of time marches on, pointed toward this order. And the grim destination, heat death, a universe stretched thin, energy evenly smeared, no gradients left to drive stars or life. Black holes evaporate, galaxies fade, and eternity sits cold and silent. A cosmos not with a bang, but with a sigh. But wait, here's the paradox. If entropy always rises, why was the universe so ordered at the start? Why did it begin in such a low entropy state? That's not what you'd expect from a natural fluctuation. It's like finding the cards already stacked, the dice already loaded. Was it chance? Design? Or does entropy itself behave differently at the edge of beginnings? Some physicists, like Roger Penrose, insist this is the great unsolved problem. He proposes wild visions. Perhaps our universe is just one in a chain of conformal cycles, each ending in heat death, but then somehow resetting into a new low-entropy beginning. Death and rebirth, entropy erased by the stretching of infinity. A phoenix universe rising from its own ashes. Others suggest the multiverse offers a loophole. If countless universes bud, then rare low-entropy starts are inevitable somewhere. We live in one of the lucky ones. Not special, just survivors of cosmic lottery bias. And then there's the unsettling speculation. What if entropy can run backward? In a collapsing universe, the Big Crunch, the arrow of time might flip. Entropy decreasing as everything folds inward. Another you, another cosmos, living life in reverse. Memories unspooling backward. Causes following effects. To you, it would still feel normal because your mind would reverse as well. Forward and backward lose meaning when the arrow flips. But here's the midnight thought. Maybe time's arrow is an illusion. Maybe all states exist timelessly. Entropy simply labeling different pages in a cosmic book. You flip forward, so it feels like flow. But in truth, the whole book exists at once. You lie very still now. Entropy is no longer an abstract law. It's in your bones, your breath, the fading heat of your body. It's in the galaxies drifting farther apart, the stars burning their fuel, the very expansion of space. You are living inside the rise of entropy, a wave you cannot escape. And yet, there's comfort here, because without entropy, there would be no arrow of time, no before or after, no memory, no story. Entropy gives you endings, yes, but it also gives you beginnings. It gives you music instead of static, narrative instead of noise. The enemy called entropy is also the storyteller, the one who ensures that your life, your universe, moves forward. Without it, you'd be frozen in timeless perfection, a flawless deck of cards, never shuffled, never played. So tonight, as the stars outside burn down their fuel, as the cosmos runs its quiet account books, you can whisper thank you. Thank you to entropy, the enemy that makes you possible. And then the darker question lingers, like a chill in the room. If entropy writes the story, who or what wrote entropy?
You thought the Big Bang was our beginning, but the universe is a trickster. It hints that other beginnings may echo just beyond reach, stories older than ours bleeding faintly into the background. Remember those ripples in the cosmic microwave background, the afterglow of creation? Some of them behave oddly, as if they carry scars, bruises, signatures of something that came before. One anomaly, the so-called cold spot, stretches across a vast patch of sky, stubbornly colder than the surrounding glow. Too large, too improbable. Explanations range from chance statistics to vast cosmic voids. But some whisper another possibility. It's the fingerprint of another universe brushing against ours, the bruise of a collision written into the fabric of the sky. Others see echoes not in the radiation, but in the mathematics itself. Physicist Roger Penrose, with his conformal cyclic cosmology, claims the faint halos of energy around black holes might outlive the universe itself. As galaxies burn out and black holes evaporate, their final whispers could echo into the next cycle, like faint embers glowing in the ashes of a fire.
If he's right, then traces of a previous universe, its black holes, its deaths, are etched faintly into the microwave background we measure today. Imagine that. You, staring into the night sky, may already be looking at fossils not just from the beginning of our universe, but from the end of a previous one, an echo across eternity. And myths, once again, seem to have guessed first. Hindu cosmology tells of Brahma's breath, universes born as he exhales, destroyed as he inhales, each cycle endless. The Norse spoke of Ragnarok, destruction followed by renewal. The Maya charted long cycles of creation and destruction in their calendars. Again and again, human imagination circled the same idea. Beginnings are not singular. They are plural. Modern physics reluctantly edges closer. The bounce models, the cyclic cosmologies, the multiverse theories, they all suggest that our bang might just be one drumbeat in an eternal rhythm. What you call the beginning might just be one crest on an infinite wave. But then comes the philosophical chill. If there are infinite beginnings, does any single one matter? Does our universe lose its uniqueness when it becomes just one stanza in a never-ending song? Maybe not. Maybe the repetition itself is the meaning. Just as a heartbeat matters precisely because it repeats, maybe universes matter precisely because they rise and fall in endless echoes. And here's a subtler thought. If echoes of older universes exist, faint but real, then maybe memory itself is cosmic. Just as you carry the genes of ancestors long gone, perhaps our cosmos carries traces of its predecessors, written faintly in the radiation, in the constants, in the strange alignments of galaxies. We live inside a memory too vast for us to read fully, a history written across light years. You roll onto your side and picture it. Universes blooming and fading, each leaving ripples, each ripple whispering to the next. Our sky, our stars, our laws of physics, gifts from a cosmos that once was, handed quietly to the cosmos that now is. And if that's true, then the Big Bang isn't the start of everything. It's just the latest echo, a voice in an eternal chorus. So tonight, as silence thickens and your breath slows, listen closer. Perhaps under the hiss of static, under the rhythm of your heart, you'll hear it, the faint echo of another beginning, whispering across eternity, reminding you that nothing ever truly starts alone. You've seen the cosmos as a bang, a bounce, a bubble, a bruise. But tonight, the story softens into something stranger still. What if the universe is a dream? Not a metaphor, not poetry, but a literal possibility whispered by physics and philosophy alike. The idea isn't new. The Hindu Upanishads describe the cosmos as Vishnu's dream, reality itself flowing from the mind of the divine. The Chinese sage Zhuangzi once dreamed he was a butterfly, then woke and asked, was he a man who dreamed he was a butterfly, or a butterfly dreaming it was a man? The Mayans believed existence was woven from the dreams of gods, fragile and fleeting. Again and again, cultures circled the possibility that the world is not material at its root, it is mental. And modern physics, reluctantly, sometimes circles the same idea. Quantum mechanics insists the act of observation shapes reality. Particles don't have definite properties until they are measured. Until then, they hover in probability, like unformed thoughts. Schrödinger's cat, alive and dead, dreaming in a box. When you look, the dream chooses. Some physicists interpret this literally. The Copenhagen interpretation suggests reality doesn't fully exist until observed. The many worlds interpretation argues all possibilities exist, each branching into a separate dream. And John Wheeler, with his participatory universe, once suggested the cosmos only becomes real through the act of conscious observation. In other words, you are part of the dreamer. What if that's true? What if the Big Bang itself was less a firework and more a thought crystallizing? A dream shifting from haze into form. The eerie part is how well the metaphor fits. Dreams bend time and space. They obey rules until they don't. They vanish when you wake, leaving only fragments behind. Likewise, the universe has rules that seem consistent, until you reach singularities, quantum scales, or the edge of time. Then the rules dissolve, and you glimpse something raw, something unformed. And then comes the simulation hypothesis, the modern cousin of the dream idea. If reality is coded, simulated, then what you experience as stars and galaxies may be no more fundamental than pixels in a game. The dreamer, in this case, is not a god, but a programmer. The cosmic egg is a server farm, and the bang, just the boot up. You close your eyes, and suddenly the thought is unavoidable. What if the reason you can never find the before of the Big Bang is because there wasn't one? What if it was simply the moment the dream began, the moment the simulation loaded, the moment consciousness cracked open? But even if so, does it matter? In a dream, you laugh, you fear, you love. In a simulation, you still feel real joy, real pain. The unreality doesn't cancel the experience. In fact, it may heighten it. If the cosmos is a dream, then meaning isn't diminished, it's transformed. You are both character and co-dreamer. And here's the gentlest twist. If the universe is a dream, then perhaps death is not an end, but a waking. Perhaps beginnings and endings are illusions of narrative. The way a dream feels like it starts at a moment, but actually unfolds from a haze. Perhaps the Big Bang was not the beginning of all things, but the beginning of this particular dream, and others before and after drift endlessly through the sleeper's mind. You lie in the dark, halfway between waking and sleeping, and the boundary itself blurs. Is this reality or a dream of reality? Does it matter? If the cosmos is dreaming, then you are part of the dream. And for tonight, that's enough. From the earliest firesides to tonight's quiet room, one thing has remained constant: the human ache to know where it all began. You can't help it. The question is stitched into your bones, as natural as breath. Origins matter. They tell you who you are, why you're here, where you might be going. Think back. Long before telescopes or equations, people tilted their faces to the stars and asked the same questions you are asking now. Why is there something instead of nothing? Where did it come from? Who or what made it? Every culture answered in its own way. The Babylonians told of Marduk splitting the body of the chaos dragon Tiamat to form the heavens and the earth. The Egyptians imagined the sun god Ra rising from the watery abyss. The Norse sang of Ginnungagap, a yawning void where fire and ice met, birthing the first beings. The Hebrews told of a god who spoke light into darkness. Myth was the first cosmology, the first attempt to stitch a story around the incomprehensible. And though the details differed, the hunger was the same: to tame mystery with narrative, to anchor existence in meaning. Then came philosophy. The Greeks debated whether the cosmos was eternal or created. Aristotle insisted on an eternal universe, uncreated, unending. Plato dreamed of a craftsman god, the demiurge, shaping chaos into order. Later, Christian theologians wrestled with creation ex nihilo, creation out of nothing, an idea at once majestic and paradoxical. And then came science, armed with telescopes and mathematics. Galileo mapped moons. Newton bound the planets in laws of gravity. Hubble revealed galaxies fleeing from us, suggesting expansion. Penzias and Wilson heard the faint hiss of radiation left over from the beginning. Each discovery peeled back layers of myth, replacing gods with forces, parables with equations. But here's the irony. The hunger never went away. The myths evolved into models, but the ache remained. You may no longer pray to Ra or Marduk, but you still search the sky for answers. You still crave beginnings. And even now, with quantum foam and inflationary fields, you find yourself back at the same paradox. Where did it all come from? Why is there something rather than nothing? Maybe this is the human fate, to never be satisfied, to chase origins endlessly. Each time we solve a puzzle, the answer reveals deeper puzzles. Each time we draw a line, the line recedes into the horizon. The Big Bang itself, once presented as an ending to the question, now spawns more questions than ever. What caused it? What came before? What lies beyond? And maybe that's the point. Maybe the hunger itself is the story. The myths weren't wrong, not really. They gave shape to the hunger, gave us images and metaphors to cradle the uncradled. Physics does the same, only with math. Both are languages for awe. Think of it this way. The universe may never hand you a final answer, but in your reaching, in your hunger, you become part of its unfolding. The question is not a flaw, it's a feature, a compass needle that always points beyond the known. And here's the soft truth, whispered like a lullaby. You may never know the ultimate origin. You may never close the loop. But the act of seeking, the act of asking has always been enough. From campfire stories to particle colliders, from myth to math, humanity has always leaned forward into mystery. That leaning is who we are. You roll onto your back, eyes closed, and feel it. The ache of curiosity, the longing that makes your chest expand like the universe itself. Tonight, you share it with every ancestor, every stargazer, every thinker who ever wondered. You are not alone in your hunger. You never were. Night settles like a curtain. The stars wheel slowly overhead, ancient and indifferent, and you lie here with the final question humming against your ribs. If the universe had a beginning, did it also have a reason? You've traveled far, from the neat fireworks of the schoolbook Big Bang, through the patched seams of inflation, the rebounds of cosmic bounces, the froth of quantum foam, the whispers of dark matter, the tug of dark energy, the dizzying sprawl of multiverses, the dreamlike edges of quantum paradox. Each path promised closure, and each one dissolved into new mysteries. And maybe that's the point. Maybe the story of origins isn't a story with an ending. Maybe it's a spiral, a labyrinth, a riddle that reshapes itself every time you touch it. Theologians frame the question in sharper terms. If God created everything, did He also create evil? It's the same paradox you've heard whispered across centuries. If perfection made the world, why is the world so broken? If a beginning was given, why was it flawed? And physics, in its own language, circles the same enigma. If laws created the cosmos, where did the laws come from? If equations describe the universe, who or what wrote the equations? Every answer points to another question. God? Then who made God? The multiverse? Then what birthed the multiverse? Quantum foam? Then why does quantum foam exist? Nothing. Then why does nothing allow for anything at all? You start to see the pattern. Origins aren't answers, they're mirrors. They reflect your longing back to you. You ask what began everything, and the universe replies by deepening your hunger. And yet, there's beauty here. Maybe the value of the question isn't in solving it, but in living with it. The cosmos doesn't hand out neat conclusions. Instead, it invites you into awe, into wonder, into the humbling recognition that you are, yes, but also aware enough to ask the questions at all. Think of the first people to look up at the night sky, to draw constellations, to tell stories about eggs and dragons and gods. Think of the monks calculating heavenly spheres, the scientists polishing glass to catch faint light from distant galaxies. Think of you, here, now, eyes closed in the dark, still carrying the same flame of curiosity. That continuity is its own answer. You are part of a lineage stretching back through millennia, united by wonder. You are stitched into the fabric of the very story you're trying to understand. And maybe that's enough. Maybe the meaning of the Big Bang, or the bounce, or the foam, or the dream is not in how it happened, but in how it makes you feel. It unsettles you, humbles you, lulls you, awakens you. It leaves you with more mystery than you began with. And that is not a failure. That is the gift. So tonight, as you drift towards sleep, carry this thought. The question of origins is endless because it is alive. It moves with you, grows with you, deepens as you deepen. You will never exhaust it, never trap it, never resolve it. But you will always walk with it, as countless before you did, as countless after you will. The night is quiet now. The stars are steady, and the universe, whether born from bang, bounce, foam, or dream, hums softly in the background, patient, eternal. Close your eyes. The question will wait.